We are working with Excel. Right now we are solving question B from problem 5. Here we can see the Word document that we have for assignment 8. This is problem 5 and we already solved question 5A in which we had to create this plot. The plot that we need to create now for question B is a plot in which we are plotting the average of the flux. As you can see, we have three different sets of data for the flux. We are going to calculate the average and plot the average flux as function of time. Then we are going to add error bars to that plot, and also we are going to be adding a trend line to the plot. So we need to do three different things for question 5B. First, create a plot of the average flux against time. Then add error bars to the plot, and then we need to add a trend line. Let's go to Excel and get started. So first we have the average calculation. Here we have the column, and we need to start by calculating the average. Just go to the cell, start typing average, and Excel is gonna give you an option. Just select this. And after you select this, you can see that Excel already opened a parenthesis, and the only thing that you need to do is to select the range of data that you are going to be using for calculating the average. In this case, this is the data that I'm using, those three data. Close the parenthesis, enter. At that moment, you have calculated the average, and then you go to the cell back, and if you put the mouse right here, you hover the mouse right here, on this corner of the cell, and you double click, can you see how the plus sign is changing? This is normal. And when I go close to the corner, it changes slightly. At that point, I can double click and Excel will fill out the missing data. That's it. So now I have all the average flux calculated. Now I need to do something similar in order to calculate the standard deviation. Go to the first cell and start typing standard deviation, ST. And as you can see, again, Excel gave me the option, select standard deviation.s right here. And again, Excel open a parenthesis for you to select the range of data. Go and select the same three cells for the data, close the parenthesis, enter. Go to that cell again, go to the corner and double click, and you have the data. So now we are finally ready to start plotting the data. To plot the data, select the data that is for the x-axis, that is time, highlighted. Then press the button Control in your keyboard. I'm holding the Control button down, and then go and highlight the average flux data like this. After you have these two sets of data selected, go to Insert, Scatter, and select the scatter plot without the smoothing right here. And now we have the plot for the average flux. I can take the other plot for question 5A and put it over here. And now I'm working on this one. As we mentioned before, the default options or the default plots that Excel give you are not good enough. Why? Because the axes have no title, there are no units, so there is not enough information of what data is being plotted here. Additionally, a big portion of the area region is being wasted by having this legend that we not even need. Why we do not need a legend for this plot? Because we are only plotting one set of data. So for right now, this legend is not needed. Simply select the legend by clicking on it and hit the delete button. Done. The plot looks a lot better already. The first thing that we are going to do, we are going to fix the title, average flux. Just click on it, space, versus time. Done. Now what we need to do is to add the axis title and make the axis label, the numbers in the title, a little bit larger. So select the plot And by selecting the plot, let me show you, I'm going to click outside. By selecting the plot, I get this green area right here, region, in which I can select the layout for the plot, select layout, then go to axis title, and let's work first with the primary horizontal axis title. And select the option title below the axis right here. This will appear, highlight it, and you can just type time, which has units of minute. Bring this down a little bit and go home and select size font 14. 14 is good size. Okay. We are almost done with the x-axis. Just select now the x-axis like this. As you can see, this is the line for the plot and this is the axis. After you select the axis, let's make the labels bold and perhaps a little bit larger. This is now very nice. If you are showing this plot perhaps in a PowerPoint presentation, sharing this with other people, these numbers are large and bold enough that anybody will be able to see what you are plotting. So this is very good. I'm going to make it a little bit closer. Now let's work with the y-axis. Again, select the plot by clicking on it. Go up here and you have this green region for the chart tool. Select layout, axis title, and now go and select the primary vertical axis title and select rotated title. And this is going to be the average flux, which is in units of kilogram over meter square second. And as you can see, we need to make the two. Let me put this in so you can see the title a little bit better. This 2 needs to be a super index, so simply go and click inside the title, select the number 2, go home, and then go to font right here in this little corner, open, and then select superscript. That's it. Then select the title and select font size 14, and then you can just enter the title so it looks nice. And the last thing that we are going to do, perhaps make these numbers bold. And I think this plot looks very nice. Do you see how different it looks from the initial plot that we had? We can then go to the plot area by clicking on it. Then click the mouse with the right button of the mouse. Go to Format Plot Area, Border Color, Solid Line. So this is gonna add a nice border to the plot, and you can select perhaps black color. Okay, so we have finished preparing the plot of the average flux versus time. This plot is very nice. The axes have very nice titles that are large. Anybody can see them. We have the proper unit. This is very good. So let's go to step 2. Let's add now the error bars. Simply select the data by clicking on the data itself that is selected. So you can see. Then go to chart tool, layout, and you can select right here error bars. So I'm hovering my mouse over this icon so you can see what I'm getting. This is error bars, and click on it and go to more error bar options right here. You're gonna select the error bars that we want. We want both the positive and the negative. So make sure that your button is right here in both your selection, and also make sure that you have caps. The caps look very nice. It's very nice to see error bar with caps right here. Now, we don't have a fixed value for the error. We don't have a percentage. We actually calculated our own standard deviation. So go to custom because we have our own custom values right here. And then click specify value right here. And you are going to go and select the data that we have for the standard deviation. This is the data. Highlight the entire range for the positive error. And then for the negative error, go to the cell, delete everything, and then highlight exactly the same set of values. So the positive and the negative error are identical. This is how it looks with both of them. And then you click OK and then close. And we have the error bar. I want to change the color of the error bar to red so that they are slightly more noticeable. Select the error bar by clicking on them, then click the right button of the mouse, format error bar, line color, solid line, and let's select the color red. Okay, so we are done with the step 2, which was adding the error bar. The last thing that we need to do for this plot, we need to add a trend line. A trend line is getting an equation that you can later use for calculating some of the data that you don't have, for example, from the table. So a trend line is fitting the data into an equation. In this case, you can see that the data has a linear behavior. The behavior is close to a straight line. So we are going to use that model. Go to the data, click the data right here. This is how the data looks when you are selecting it. Then click the right button of the mouse and go to add trend line right here. So I hope everybody can see add a trend line. You are gonna go and select linear, and also I want you to display the equation for the trend line and the R value. The R value is important. It's called the correlation coefficient, and it's important because it gives us information about how accurate the trend line is. In this case, we want to have values that are very close to 1. In particularly, it's very good when the value for the R squared is around 0.95 or higher. So make sure that you have a check mark here and display the equation and display the R squared value. So linear, you select linear plot, display equation and display R squared value and then close. And this is the equation that we have. Let's now modify this legend. Do you see the default equation that Excel is giving you? We have the first value is 3 10 to the minus 5. It's like, really? It's 3? We need to add a little bit of more significant figures, at least 2. Excel by default will give you very rounded numbers. It's not good enough. All the defaults that Excel has are not created for engineers. So you really need to work on your Excel files and your Excel plots and modify them so they are good engineering plots. So select the legend. We are going to put a white background and a border. Format trend line label. Field, solid field, select white color. Border, solid line, select black. That looks a little bit better. Now let's work on the numbers. Select again the legend, right button of the mouse, format trend line label, and go to number. And we are going to select scientific notation with 2 decimal places. So let me do it again. You selected here number, then in category you select scientific right here, and then you will use 2 decimal places and then close. And we can see that the value was not 3, it was 3.27. This is the slope, this is the value at 0, and here we have the value for R squared, which is 0.98, which is very good. We are almost ready with this plot. There is only one final thing that we need to fix. And if you look at the label of the y-axis, we have trailing zeros. That is, we have right here extra zeros that we do not need. That is very easy to fix. Just click on the values. That's how you select the axis. This is how the axis looks when it's selected. Then click the right button of the mouse. Then select Format Axis right here. Then go to Number. And then we need scientific notation. So let's go and select scientific. As you can see here in blue, I am selected scientific. But then go right here to decimal places and type the number 0 because we don't need the extra 0. Close. Then perhaps click on the plot, pull this a little bit to the side. And if you look at this plot, this is a professional engineering plot. It has a proper title for the plot. We have proper title for the axis. And the labels in the axis are nice and clear. We are ready to copy and paste this plot to Microsoft Word. Simply click on it. Then go Ctrl+C to copy. We can go to Word. Select this space right here. Go to Paste Special. As you can see, I'm selecting Paste Special. Then go to Picture as Enhance Meta File and go OK. This is the plot. The only thing that you need to do perhaps is to center the plot, and this is ready. We have now finished question 5B.